Hi, I'm Martin and welcome to Groundhog Graphics. This is Chapter 3, Programming in C. In this chapter, we are going to be talking about conditional branching in C, which C only has two ways of doing conditional branches. It's really two ways of making decisions, and we're going to be going over both ways in this tutorial. So let's begin by creating a new project. We'll create a console application, C application, project title, chapter 3, example 1. Defaults are fine. There we go. Now let's open up our source file and we'll delete all this. Alright, now we'll start by including our standard input-output library. Int main void. Alright, we're going to start by printing to the screen. Let's see here. Enter a number. Alright, semicolon. And we're going to use scanf. Open parentheses, open quotation, and we're going to take an integer number. So we'll use D for decimal, and let's put num1 for number 1, semicolon, and enter a second number. Semicolon, scanf, take another integer, %d, number 2, and semicolon. Now we need to find our variables. We come up here at the top. Now in C99 you can technically, you can put your variable declarations anywhere in your program. I'm used to C89, and it's an older version where you have to put your variable declarations at the beginning of a function. You can't put any function calls before that. So I also think it's more orderly to put your variable declarations at the beginning anyway. It's easier to keep track of. So let's go ahead and make int integer num1 num2 semicolon. Okay. Now what we have here is I'm going to type if num1 is greater than num2, then I'm going to puts, let's see here, actually let's do a printf. Printf %d is greater than %d, so comma num1 comma num2 semicolon. Alright, so here's our first chance to look at a conditional branching statement in C. Now what it's called, well, it's called if. It's an if statement. And the if statement, it consists of the if and then the expression to be evaluated next to it. And how it works is if the expression evaluates to be true, then it will come down here into these blocks and it will execute whatever is in between these open and closed curly braces. If the expression is false, like if number 2 is actually less than number 1, then it will skip this code altogether and continue down here. Now, with the if, we also have an else. So if the situation, let's say if the condition number 1 is not greater than number 2, and we put an else statement, Then whatever happens, we'll execute this code, and we can we can print f, and we will go %d is less than or equal to %d / n semicolon there, and we'll put num2 comma num1, and then I come up here and put my \n here. Alright, so now what we have is we have if, open parenthesis, test for expression is number 1. Oh, here's something we forgot to do up here. Put our ampersand sign in. Okay, now if number 1 is greater than number 2, if that evaluates to being true, then this printf right here will get executed. And if this is false, it will fall down here to the else, and it will execute this instead. So let's go ahead and run this program and try it out. F9. Enter a number. Okay, 20 and 30. 30 is less than or equal to 20. Okay, that's wrong. So let's see what we have for a bug to work out. Oh, here is the problem right here. We should put num1 and num2 in their respective places, and then I believe our program is going to work fine. So execute, and we'll try 30 and 20, and it says 30 is greater than 20. Okay, and then let's run it again, and let's try 20 and 30. 20 is less than or equal to 30. Okay, and let's try one more time and make the numbers equal. 30 and 30. 30 is less than or equal to 30. So there we go. Now it works fine. So now we've learned how to do a very simple if statement. Now let me show you some of the different options we have. Okay, so now we know how to check if number 1 is greater than number 2. But let's get rid of this else right now, and let's put in another if statement. If num1 is less than num2. Open curly brace, close curly brace, and we'll put printf %d is less than %d \n for new line character, comma num1, comma num2. And then underneath this, so we know that now if num1 is less than num2, we know that it will print that it is less than. And we have one for greater than up here above, but what we don't have is what if they are equal. So let's put that in. If num1 is equal to num2, oh, down here. Now you notice, now I have if num1 is equal with two equal signs for num2. Now when we are comparing two values in C, you have to use two equal signs, because one equal sign means that you are assigning a value. So if I took away this one equal sign here, num1 would then equal num2. It would assign num1 num2's value. So then we will print f %d is equal to %d. Num1, num2, and now we have all three different possibilities here: greater than, less than, or equal. Let's go ahead and run it and try this. Enter a number. number 1. Number 2. 1 is less than 2. True. Now, enter 2 and put a 1. 2 is greater than 1. That's right. Notice none of the other code executes, just the print statement enclosed in the if that evaluates to true. Now, let's make them equal. 2 and 2. 2 is equal to 2. So when we use the if, we don't have to have an else clause after it. You can optionally have it, and it's almost like a default. So if the expression doesn't evaluate to true, then it will default to the else. But if we have a situation where we don't want that, which there are a lot of times we don't, then we can omit the else. So it is optional. What we're going to do now is talk about relational operators in C, and there are 6 of them. So let's go ahead and create a new project. Console application C, and the title of this will be Chapter 3, Example 2. Yes. Finish. Yes. Yes. Okay. And we go ahead and delete all their stuff here. Include stdio.h and main void. Okay, so now we can see the 6 relational operators in C. The very first one, and this can be a variable or a constant value. It could be an expression, it could be, mathematical equation, it could be a lot of things. It's a comparison, and this is how C compares things. And actually the if statement, it just works on whether it gets a true or false condition. So each one of these conditional operators returns either a true or false condition, and that's it. So this one would be testing like if A, 2 equal signs equals B, and we see it says equal here, and if it was 1 equal sign, that is an assignment. That means we are assigning the value of B to A. Okay, but with 2 equal signs, and this can be an easy mistake to make when you're working with an if conditional statement, because sometimes you'll be typing and you'll type 1 equal sign, and then you'll be wondering, because your program will compile and run, and you'll be wondering, what is going on? Why is this not working? And it's because you didn't put the second equal sign in. Next, we have less than. A is less than B. A is greater than B. And then we have A is greater than or equal to B. And if you see, the greater than sign and the equal sign have to be in this order. You can't put equal sign and then greater than. You'll have to put greater than, equal sign. Same goes for the next one. Less than, equal. So A is less than or equal to B. And our last one is A is not equal to B. And the exclamation point means not in C. So these are the 6 relational operators that you need to know for working with the if conditional statements. So now that we know that, let's go ahead and comment this code out, because this isn't C code. This is just to show you what I'm talking about here. There we go. Let's see if I can make this tab over. So if you select text and code blocks and you hit the tab key, it will tab all of it over together. So that's kind of a neat feature. Okay, now there was an inaccuracy in my, I believe it's chapter 2 video, when we talk about the get character function. And let me put A equals getc stdin. And let's say it was character A. Now, here is the inaccuracy. Character A, and we're using getc stdin to get input from the keyboard, and the character value will work fine for that. But what actually the return value of A should be defined as an int for an integer. And the reason why, let me comment this out. The reason why is because getc can get input also from a file. If it gets input from a file, it will return a -1 when it reaches the end of that file. And with character has a range of 0 to 255. It does not have the negative option for a -1. So when getc would return the -1, character would think that that was actually 255. So it wouldn't realize it. So the return type of A, when you're using getc with a file especially, make sure that A is an integer. Another thing that was also an assumption on my part that was inaccurate is getc is not actually a function. Getc is a macro in C. It looks like a function, it behaves like a function, but it is not actually a function. And as we progress through the tutorial series, I will show you what things that we need to watch out for when using getc, so that we don't, or not getc, but any kind of macro that's built into C. I will show you things that we need to watch out for when dealing with macros, because there are some slight subtle differences that could cause problems. But in general, the getc looks like a function and it works like a function, and that's okay to think of it like that for the most part. But technically, it is a macro. And I will also be teaching you macros. So we're just not ready for macros yet. We will get to it. And I just wanted to let you guys know. So I'm going to go ahead and make comments on this. Okay, so now we have that commented out. So now let's do some tests to see how these relational operators actually work. Let's do a printf, open parenthesis, open quotation, %d, \n, and let's do another open parenthesis. And I don't know if this open parenthesis would be technically required, but an inner open parenthesis in C will make sure that this little evaluation we're going to do is going to be very much self-contained. Okay, and it just kind of makes it clearer for if you're rereading the code too. So let's go 1 equal to 1. Now what this should do, actually, let's change this a little bit. Let's go, because I don't want the output to get confused here. What we're doing here is printf %d, so it's looking for an integer. And what we're doing is we're going to compare if 2 equals 2, because these relational operators will work even outside of if statements. They'll work in this situation too, and they will return, if 2 equals 2, it will return a 1 for true, and if it does not equal 2, it will return a 0. So let's go ahead and hit function F9, and let's see what the output is of 2 equals 2. The output is 1, which is true. So let's see what happens if 2 equals 3. On my keyboard I have to hit the Fn and F9. So F9, and there we see now it's 0 is false. So now you can actually see the actual results from using these relational operators. So that's really cool. Let's do another one. Let's do all of them. %d \n and comma, and I'm going to go ahead and actually copy this and just paste it to make sure we have 6 of them. So we can just try them all. Control C. So that's 2, 3, 4, 5, 6. Alright, now we can go in here and we can put, let's start using some variables. So let's go A is less than B. Yeah, let's just use the A and B. And A is greater B. Yeah, that's cool. And we'll do A greater than equal to B. Yeah. And A is less than equal to B. And then we'll define some values for A and B so we can change them and see what our outputs are. A not equal to B. And then at the top, I guess we should print, let's print what the values of A and B are. So printf, let's see here, A equals percent D backslash N, and then I'm going to go ahead and, because we do a new line character here, I'm going to go ahead and put the B in here as well, but they'll actually be on 2 separate lines, which I'm sure you already know by now. So B equals percent D backslash N, and then we could put over here, put our A and B variables. And then at the top, now you technically don't have to, of course, to always define your variables at the top, but I like to do that. So we go int A comma B. Oh, now here's a good opportunity to show you something else too. Int, when we declare a variable, we can also initialize its value and separate each variable. We can separate them by commas. So if you're going to declare a bunch of integers and say in one program, you don't have to write int all in a row. You can just separate them by commas. So let's say we went A to equal, int A equals, let's say it equals 2, and let's say B equals 2. Alright, we'll make them equal for this run. So I think we're good to go. Let's go ahead and test our program and hit F9, and we'll compile and see what we have. So A equals 2, B equals 2. Oh, but you know what would be better? Let's even make this better, because that was just a whole bunch of zeros and ones. That doesn't tell us a lot. So let's say nice. Okay, well, I probably, yeah, I'm sure I fast forwarded this last part, so you didn't have to see it. But what I've done here is I've typed in, all these, so we can see actually what we're doing here is A equal to B, and actually I should write that just like that. Let's put that in there. Equal to B. Yeah, that sounds better. Okay, now I got it all finished. So now we can actually see what we're doing. We're doing our output. So we print the values up here at the very top, A and B, and then we go is A equal to B, and we'll count a 1 is true and a 0 is false. So we have all these right down here to let us know which test we're actually doing with the relational operators. So let's go ahead and try to run this code with F9. There. That's oh, I forgot my question marks, but still. Okay, so A equals 2, B equals 2. Is A equal to B? No. It says A is not equal to B. Why would it say that? A and B are both 2. Oh, that's why, because I didn't put A and B in there. A equal to B. All right, try again. So, is A equal to B? 1 is true. Is A less than B? No. Greater than B? No. Is greater than or equal to B? Yeah. And less than or equal to B? Yeah. And A not equal to B? 0. Perfect. So 0 is false and 1 is true. That's all right. And that's how we can use the relational operators. And that's how if can determine, should I execute the code after in the next code block? I mean, the code block after it? Or should I skip it? Is because these relational operators, but they work independently. So that's really neat too. And we do use them independently in C quite often. So this is a very powerful feature and something just to keep in mind. Let's see. Let's go ahead and change and let's make A equal 3. And let's see what our output is. Okay, so now A equals 3. So is A equal to B? 0 is false. Is A less than B? Nope, 0 is false. Is A greater than B? Yes, 1, true. Is A greater than or equal to B? True. Is A less than or equal to B? False. Is A not equal to B? And that is true. So look at that. Isn't that neat? All these operators are relational operators actually functioning in this way. We can print the output. I think that's just amazing. It's a lot of fun. I love C. I just love programming, so I get excited about simple things. But this is really neat stuff, and you can do a lot of things with these relational operators. So now I think we have a good idea of relational operators. Let's go ahead and let me teach you some logic operators that we can use with the if statements as well. On second thought, this video is already getting kind of long, so I'm going to continue this into another video. However, we're going to restate chapter 3. Whenever in my videos, whenever I want to continue something and I have a chapter or whatever, I'm going to make it a .1. So this will be a 3.1 if you're looking for the next video. And if I have anything that way, if I have anything later on to add to something that maybe I could have missed or just something I find out, I can always put it like a 3.2 or a 3.3. So the next video, look for a 3.1. Thank you for watching. Please subscribe, and I'll catch you later. Bye.